start the tutorial 2. And before we start the tutorial 2, I think the important ones, which are, I think we have gone through the lectures, if you remember that. The first one is definitely the different deep learning models, the conventional neural network. We have seen the CNN, so we are not going through the details, but please remember these are the things we are going to consider. And then following that, RNN autocoders. Then we have also seen a little bit of DNN and how the GAN is important when we talk about creating synthetic damage data, right? Similarly, we have also talked about the reinforcement learning yesterday. So now, before getting into the step 1 or the tutorial 1, let's try to have a quick look into the how these different techniques work in the structural health monitoring. So they are basically showing the strength, limitations as well as the applications. So you can see compared to the machine learning model, how the deep learning or the other models are showing the strength and the application results. This is a very good table to have a look into that. So now let's start with the first problem. So as I said that we will start using the PyTorch today. So basically it is the implementation of CNN based image classifier tool, and as we have seen in the last lecture. And what we will try to do today is that we will try to perform a practical step-by-step implementation of a conventional neural network for image classification by using the PyTorch, okay? And for a CFR 10 data set, right? So the first step is definitely building a deep neural network using the PyTorch, and then we will try to focus on implementing the CNN-based image classifier. And before we begin the training of our model, we need to also import some of the necessary libraries and set up the environment. So I think you all must be aware of PyTorch for building and training the model, right? And then you also, so I hope you have the PyTorch which has been installed, and then the Torch Vision. So please remember that you should be able to having all of these models or all of these libraries in your MATLAB. Can you please make sure that you do install all of this? One is the PyTorch, then Torch Vision, then Matplotlib, then NumPy, then SSL. Can you let me know that you do have all of these libraries installed, everybody? Are you all okay with this? You all do have this? Okay, perfect. So now let's then move ahead with the final stage, okay? The next one. So now we are trying to import the libraries and setting up. So first is that we will try to import the Torch Vision, which will bring in common vision datasets. And so we have written import Torch, okay? And this we are using for image transformation and visualization. So we are importing the Torch Vision here. And the next step is that we will import the so one is Torch import is done, then Torch Vision is done, then we will be, so all of these libraries we are going to import here, okay? Similar way we are also going to import the NumPy as well, and then we will be importing SSL. So can you let me know if you have done this and you have imported all of this? So one, this is being imported, all is being done. Then we will set the SSL test text here, you can see this one, to create default. That means we try to context the bypass certification error, right? And this is we are going to do to control our flaws for better visualization. So now can you let me know if you have done this? And the figure size we have taken as 14:6. So you can change it if you want to, depending on the size we have taken it 14,6. If you want to increase it, decrease it, you can change it accordingly, okay? So once your importation is done, can you let me know that you have done the SSL and plot one? And as I said, if you need to import all of this, it has to be available in your MATLAB library or the Python library, whatever you are using. Done? Everybody else, is it done? Should I move to the next one? Then let me know once you are done. Yes. This is all you have to kind of import. This basically we kind of use to adjust the security image, right? Or to bypass the certification. Should we move to the next one? Everybody? The first one is representing the figure and second one is representing the figure size, right? Okay, so I am moving to the next one, right? Okay. So now we will try to step by step talk about the data transformation plus loading the CI right? So let's go one by one. So first we define the transformation pipeline, and how we do that with the transform.combo. This is the term we use for it, and this is actually let us change the multiple processing step by step, which is going to learn every time when an image is going to be read. Okay. So now if you will try to look into the inside the pipeline, you can see that we have used to tensor, which converts each of these PIL image to a PyTorch tensor, and that will scale. If you look into this one, that will scale the raw pixels from 0 to 225 to 01. So can you now write it down using the torch vision transformation to tensor? And once you will be doing that, then we are going to do the normalization, okay? And we are going to take the mean and standard deviation for that. That means we are taking the mean and we are trying to, with standard deviation, trying to standardize each of this RGB channel, right? With mean as 0.5 and the standard deviation as 0.5. And this is going to help you to keep the inputs on a constant scale, right? And that's going to be stabilizing and speeding up your process. So now once you're done with the normalization, can you let me know once you're done? Have you done till normalization? Any problem, anybody? Sorry? Integration? Anyone, have you done till the normalization? once you are done with the normalization, then you need to create the training set, right? So anybody has any problem till normalization? Have you taken the mean and standard and tried to get this line? We're using the transform normalization term here. Should we move to the next one? Have you done till normalization? Have you done that? Okay. Then can you try to create the training set with the term Proj vision datasets by using this CIFAR 10? And once you create the train dataset, then similar way you also create the test dataset, right? And that is going to prevent the distribution drift as well as make your accuracy very comparable. So once you create the normalization is being done, can you now create the train dataset as well as the test dataset by using the CIFAR 10? Have you done that? Anybody else? Okay. Anyone has any other difficulties to create this? Are you able to create the train data set as well as the test data set? Okay. So now let's try to move to the next one, the next step. Here we will try to create the data loaders, right? So now how will we do that? That once our data sets are ready, then we wrap up them with the PyTorch data loader. And the data loader will try to handle the heavy lifting for us here, right? So first what we will do is that we will try to do the batching for the optimal shuffling, right? And that's what we have done. We have set a batch of 128 here. That is big enough for the good GPU or the CPU throughout, and they are stable gradient estimate, right? So can you try to kind of define the batch size? Once you define the batch size, then you will need to train the loader. And that is going to create the training pipeline that will yield the mini batches of the image level. And each of that is going to pass through the loader, and that is going to feed the model one batch at a time. So first you need to define the batch size, and then you need to define the train loader. Once you do the batch size, then you do the train loader. The next one is similar way, you do the trace loader. So trace loader is very similar. That is going to provide the batch data for evaluation. So we usually do not shuffle the test data, so that's the result of reproducible, right? So with this kind of loaders, then our training loop will become very simple and very fast. So once you define your batch size, you do the train loader and then you do the test loader. And here we are taking a batch size of 128. If you want, you can also kind of do more or less than that. And then we are creating the data loader for both train and test sets, so that we can manage the batching and easy iteration. Done? Anyone else? Done? All of you? Okay. So now the next step is the visualization, the sample images, right? So our data loaders are ready now. The next import is to step is to visually confirm that our data is in pipeline and they are working correctly. And for that, first we will create the iterator for our training data loader, and that's what we have done with like data using equal to ITR, that train loader, right? And then we get in one batch of an image that we label using the image level equal to next data level. Can you try to do this? And after that we will kind of create the grid of images. First you try to do the first two, and then we will create the grid of images, then we will display the grid of images. Okay? So here what we are doing, here we are using the visualizing the sample size. So once you extract the batch, then you are going to use the torchvision.utils, and that is going to arrange the first 25 images from the batch into a grid. You can see that I have defined this as a 25 here. If you want to change it, you can change it, that is up to you. And you can see that I have also tried to normalize this, as well as I have also tried to use the padding here, which I have given it as 1, so that it will look nicely. This grid will actually give us a very quick visual overview of our training data. Okay? And now if you plot it, can you show me how it actually looks like? Can you try to show the plot, what you got? You got this? Okay, perfect. Yeah. Anybody else? Can you show me what plot you got? Yeah, correct. Anyone else got the plot? Can you try to get the plot and show me what you got? Yeah, right. Yusuf, you got it? Yeah, you can just show from there. No, you can show from there. Just okay, show. You come here. Follow me. Just take clear. Sarah, install and actually install. You try to install all of this library.
Let's see the problems. I think everything is there. Everything. Okay. I think something is connected with the coding again. Maybe some comma or something.
Anyone else got this image? Yeah. I think 4 of them got it. Anyone else? You got it? Okay. Take your time, that's okay. Isn't it slow here? They're still waiting there. Unless they will finish. Yeah. Unless they will finish it up, we can't go to the next step. Let me know once at least most of you got this image. If you get stuck somewhere, let me know as well. Basically, have you taken the photos of it? So take the line, taken the photos of all this line. Maybe there is some missing comma or some bracket as there on the first part. Got it? Go and check now what this particular one. No, she's doing the same thing. Same one she's doing, but somewhere I think they are not able to type or something. Both the that's a tool lecture. Yeah, she's doing in Python. Yeah. Sums and all they are also. Okay. Understood where is the mistake? There is some space or some bracket problem is there. Are you using MATLAB? Are you using MATLAB? Okay. Python? Got it? Got it? Okay. Okay, then we are moving to the next one. So once you got this image, the next step is to analyze the data sets to find the class distribution. Okay, so what we are doing in analyzing the data of class distribution, we will collect all the class labels from the training data and then we will count the occurrence of everyone, right? So for the first one, as I said that we will look into, yes. So this is very, very important because we need to know how many samples we have per class and that is going to help us if our data set is balanced or biased, right? Similar way we have done for each of the batches, we have taken this and we try to train the train loader by using that, we try to train the data and x and y is the data, and then we are trying to extend the class with this, right? So we start by creating an empty list called classes, right? And then loop through our tail loader to collect all class labels from each of the batch. Okay? And then each of this loop we will try to extend. That we are going to do later. First, can you try to do the first part? So the first line is that we have tried to create an empty list of class, right? That's what we have done with other classes. And then what you can do is that for each of the loop, we extract the images and labels, and here we have stored it as x and y, and extended our class with those labels. You can see that. So classes dot extend is going to be y to list. Next step is using the numpy, but before that, can you try to do till the extension? Once we are done with that, then we will use the numpy unique function to count how many times each of this class appears in the training data, right? And then we get the class names from the data by using class to IDX here. You can see this one. So we can label our chat very, very correctly. And then finally, we will try to plot as a bar, where the x-axis will show the target class. You can see that x label we have showed as a target class, whereas y label will show the number of training instances. So the x1 will go, x label will show this and y label will show this, and then finally we will plot it. So can you try to plot this and let me know how it could look like? Anyone else? The x and y axis as well. Can you show me? Oh, okay, fine. Got it? Yeah, correct. Anyone else? What the coordinates are? Anyone else got the plot? Yeah. many you got? How many of you got this lot? Got it? Okay. So now let's go to the next one, and here we will try to build a CNN architecture. Is this enough clear to all of you? So first we will try to do is that here we will try to focus, as we said, that we will try to build a conventional neural network, right? So the first step is that if we will try to look into this. Can you see now? Yes. So we will be trying to build the CNN architecture here for the classification, right? So as we said that, let's try to do the first step at a time. So first we will try to define the class CNN by using the torch-NN module, and then we will be defining in the initial self, right? So can you try to first line write down the CNN and get this class, and please remember that it has to be installed in your library. Yes, I did. No, it is visible online. Not visible?
Now it is
Yeah, I mean they can share it. No, this is from level. Can you check it again? So now if I am zooming in, can you see the zooming? So maybe some internet issues are there. Yes, hi Vivek. So you can see that I have tried to define the image size and number somewhere, right? So you can change that one, and if you use a different type of like if you don't use a CA10, then definitely your model will become like more complicated. So if you let me just show you the. Yeah, so here you can see that I have tried to, or I have talked about the torch vision, and I have inputted the CFR10, right, to train the data set. So if you are not going to use that, then definitely you have to define the size of your pixel, define the size here. So you can see that I have also talked about the figure and the figure size. So those are the things you have to change according to that, right? So here I have tried to take in a very normalized case, but if you will take something more complex, definitely the whole process will some way similar, but yeah, so here is the term where you are defining the train loader or test loader. Before that, you have to define all of the test data set and details of the test data set, right? So basically nothing but here I have defined, if you will see my cursor, here I have tried to define it using the CFR10, but if you don't use this one, then you have to, whatever data set you take it, you just load it here. And similar way for the test data set also, you just load it here. So it's going to be not too much different, okay? The whole process is same, only the training and the testing details is going to be different. Is it clear, Vivek? Okay, I think I was muted. Okay. Yeah, so Vivek, is it clear to you? Okay. So yeah, so now once you have done till this one, have you taken the padding equals to 1 and have you done till this? So once you will be done with this one, then we are going to use a term called RUL. And this is basically the 3 sets of convolutional neural network we are going to use, and each will be followed by an RUL action, right? Or activation that to maximize the pooling layer. So that's what we have done it here. We have used the torch in RUL, and then we have talked about the maximum cooling 12D, right? We have used the kernel size equals to 2. Similar way, we have also talked about the output as well as the padding one. So now if you will try to kind of rewrite the whole thing, basically we have tried to kind of first did the class definition, right? And then we can see that we have done is the sequential model block, okay? And then we have done the second conventional block. So now first if we try to define the CNN, have you done till this one? So here you can see that for the channels I have given 32 as a first your input channel, and we have given 64 as an output channel. So if you want to change the number, you can also change that. That depends on whatever number you want to give. And again the kernel size I have given as size 3, and here. Similar way we have also done the RUL pool and the max pool layer. So once you done with the RUL pool, then we will go to the max pool, the second line, and then we will try to do the conventional blocks, right, by using the dot NN dot conventional 2D. And for all of the cases, the channel input and output we have kept it similar because that's what we wanted. Similar way the kernel size also we have kept it similar, which is 3. And the padding we have taken 1 from the beginning, that's what we have taken from the beginning, 1, right? This is basically the 3 layers we are introducing here. Okay. And again, as I said that I have taken a certain values or the certain numbers, but whatever numbers you are considering, it has to be somewhere similar. Then you will be getting somewhere similar looking curve. Like the similar way you can see that the second layer maps I have taken from 512 to 10. That's why I have written as NL linear equals to 512 comma 10. And that is corresponding to the 10 classes, right? And at the last what we have done, in the last forward function, we simply pass the input x, you can see this here, in forward self comma x through the model and then return the result. And this will give us the predicted class scores. Have you done this thing? Should I move to the next one? So next step is that we will configure the training process. So have you done till this one? Done? All of you? Okay. So the next step is the configuring the training process, and we will choose the compute device and then create the model on the device here, right? And parameters. So So the first we have, that's what we have done it here. First line is that we have written device equal to CUDA, and then if torch equal to CUDA is available, that means if GPU is available, we use CUDA. Otherwise, we fall back to the CPU. Okay. And then the next one is that we will try to model the CNN. That means we will try to instantiate our CNN model and move all the parameters onto that particular device. So the computation happens at the same place, right? And then the next one is that we will use the NAM epochs and then we have given as a 50 because we will train for the 50 passes over the data set. That's why we have taken as a 50. And then the next one is that we will try to control the optimizer step size, a good fall for Adam. And that's what we have written as an learning rate equal to 0.001. So now can you try to first define the device and then model the CNN into the device. So once you are done initiating the CNN and move all parameters onto the device, then we will go to the next one. Have you done this too? Try to check at home, and then if you see that if you don't get it, let's try to go to the next one, right? Because we have 2-3 other steps, okay? So the next one is that we will try to train the model, okay? And then what we will try to do here, you can see that we will loop over all aspects, set the model, and to train the model for each of this batch to forward the batch, right? And then compute the loss, backprop, and update the base. And that's what you can see that we have actually done it here, okay? Step by step. So you can take a photo of this and go back and try to write down the same, you can use the same code actually, and then you will be getting the print. So here you can see that at the end we are getting the training loss data or the list of that. That means that will complete epoch and will repeat all the epoches to fit in the CNN. 1 minute, yeah. You can take a screenshot of that. So once you will try to model or try to do this, you will get something like this. Okay, and this is basically nothing but the output of your training loop from the previous step, right? So once you will do that, then you should be able to get an output like this. Okay, and I hope you have taken the screenshot of the codes. You don't need to take the screenshot of this. This is going to be like very similar looking. So this is fine, but this is something you have to do that. Let me just zoom in for you. So once you get a training loop like this, right, then the next step is that plotting the training loss. And that's what we can do by visualizing how the loss has been changed over the training process, okay? And that's what we have done it. We have plotted the plot range, and then we have also plot the train loss list, right? And from that, from the x level or with x axis, we have given the number of epochs, and the y axis we have given the training loss. And then if you will try to plot this, okay, and this from this plot also, it is very you can see that the model is continuous or consistently decreasing. So this is the something and final result you are gonna get it, okay, which is going to show you in the left hand side, and in the y axis you are going to get the training loss versus the number of epochs, okay. So if you will do this properly, then you will be able to get a graph like this, okay. So now once that's been done, the final step is that importing or the evaluating the model accuracy, right? And this is how you can do that. You can switch the model to the evolution mode by using, you can see that you can just use this model.evolution this time here, and by similar way you can take the image and label as a test loader and further put it there as an output as a model image, and then you can print the test accuracy. So I have given as an 100 because I want to compute the percentage over all the test samples, right? and print it. That's why it has been 100. So if you will use this one, then you can evaluate the model accuracy from there. And the next stop is going to visualize you the model prediction, and that is the final stop or the final stage where you can actually test the batch and select a few image and gather, and that's what I have done it here. So you can see that I have taken num image equal to 5. That means we will show the 5 examples. Okay, you can increase it also depending on that. So I have tried to show the 5 examples from the test batch. Okay, and then similar way that y2 name we have given as name y2 equal to this one. So this is basically the time the 2 level indices into the readable class. Similar way we have also done it for the y-feed name as well, and this is also do the something similar. And then similar way we will try to look into the plot in show. We can show the plot title we have given, the plot axis we have not given the plot axis because we want to see just the images. And now if you will try to plot this one, you will be able to get up something like this. I can send you the all the codes actually. If I think Shivu, you have the email ID, right? So I can send you the all the codes so that you can just use it. Okay, yeah, I can send you all the codes for today and the last week, so you can just try to practice and get something like this. Okay. But it's all in MATLAB. So if you use the Python, the terms will be very much similar. Only the I think some of these details will be a little bit different. Okay. But yeah, as I said that, so here what I have done is that I have used the PyTorch and used the CNN based approach. Similar way you can also do for TensorFlow, right? And similar way you can also use some other kind of neural network and try to get something. So here I have shown you the image one. You can also do for text. You can also do for the time series. Similar way you can do that, right? So my suggestion is that once you practice this, try to kind of use it for different ANN kind of approach or different text images and see that what is the way you will be getting it, right? And another thing is that if you are not sure about the CNN based or ANN based approach nowadays, so you need to simply to use those things. Okay. Fine, then I think and then please get back to me. I think as I said that, and then you will be online some problems. So try that. So okay, then I think if you don't have okay, so if you're stuck in the, you can just get. I will the doubts with you. Okay, then, and let's see if we have. Do we have any online? Then I think we will see you all tomorrow.